Okay, so let's see how many problems we can solve today. Um, so we'll begin with, tulad ng sinabi ko sa inyo last time, magsisimula tayo sa oscillations, problem na oscillations. And we'll begin by discussing one of the, or two of the exercises or problems na nandun sa book. Okay, specifically itong problem na ito at saka yung next problem. So, yung concept ng oscillations doesn't necessarily need to be confined dun sa physical systems na anong tawag dito ng moving objects, okay? Any oscillating system ay pwede niyong i-apply yung concepts na natutunan natin before. The only idea or the only thing that you need to do is to translate yung uh, is how to translate yung mga parameters from yung physical system to the oscillating system. Like in this example. So sa example 3.4 dun sa book. Okay, yung oscillating system na kino-consider dito ay is an electrical circuit. Okay, so we're going to consider two examples. Yung first ay yung electrical circuit without any resistance, and yung second is an electrical circuit with resistance. Okay, so dito sa first example, we need to find the equivalent circuit for the hanging mass spring shown in figure 3-17A, and determine the time dependence of the charge Q in the system. Okay, so if you recall dun sa spring, okay, yung ating differential equation na nakuha natin from applying Newton's laws is given by x double dot omega naught squared x equals 0. Okay, so walang damping, walang forced oscillations. And yung solution na nakuha natin dito is x equals x equals a times cosine omega t minus delta. Saan yung omega, not t, sorry. Yung omega naught t ay yung frequency ng oscillation, which is basically given by the spring constant divided by yung mass ng spring. Paano naman dito sa electrical circuit? Sa spring system, itong equation ito was derived using Newton's laws. Sa electrical circuit, anong ginagamit natin para mabuo yung differential equation? So here, ang ginagamit natin dito ay Kirchhoff's laws. Okay, so Kirchhoff's rules. So sa electrical systems, we use Kirchhoff's rules. Okay, so dito we consider a direction of the loop. Okay, so meron kang driving force which is yung EMF. Okay, and yung direction nung current na dinadrive nung EMF na yan ay in this direction. So counterclockwise. So using Newton's laws, we have first of all yung voltage drop across the inductor. Ang voltage drop across the inductor, okay, is let's say VL, and then yung voltage drop across the capacitor. At lahat yan ay equal dun sa EMF. Ang voltage drop across the inductor is given by the inductance times the derivative of the current with respect to time, and yung voltage across the capacitor is equal to the charge divided by the capacitance. So equal yan sa equal sa E. Okay, if we consider time varying variables, okay, we're going to write I and Q in small letters. Okay, so papalitan natin to. If we need to consider time varying variables, dapat small letters yan. Okay, so L di dt plus Q over C. Now we also know that I is equal to dQ dt, so that L d squared Q dt squared is equal to Q plus Q over C is equal to EMF. Or Q double dot plus Q over LC is equal to yung EMF. Now, sorry. over L. Okay, now, itong E over L na to, okay, will have units of charge per unit time. Okay, yes, charge per unit time. Paano natin alam na charge per unit time yan? Hindi. Charge per unit ng square root of time. Okay, kasi yung time, yung LC is the time constant. Diba? Tama. So, charge per unit time. Ang Q is charge, and then LC is the time constant. Okay, so now if we compare this equation, okay, if we compare these two equations, okay, other than yung driving force, okay, ang tawag dito, these equations are basically similar, right? So let's say na itong E of L na ito, let's put this E of L as Q1. So it's charge. Charge per unit, per capacitance, okay? Hindi. Yan, ganyan. So, this means that yung ating equation is Q double dot plus Q minus Q1 over LC is equal to 0. Okay, so now we have a form, okay, Q1, okay, that is similar to, okay, to this. Okay. So essentially wala na yung driving force dun sa right-hand side. Nilipat lang natin sa left-hand side. And we can do that because Q1 over LC is just a constant. The driving force is not sinusoidally varying. So we treat it as a constant and put it on the right-hand side. And we can see that this form is precisely this form. And from here, we simply write the solution. Okay, remember that Q, okay, lagay natin sa next page. Q double dot, okay, ulitin natin plus omega naught squared x equal to 0, x is equal to a cosine omega t minus delta, na kung saan yung omega naught is equal to square root of k over m. And here, now we have q double dot plus q 1 over LC, Q minus Q1 is equal to 0. Okay, so by straightforward na analogy, okay, makikita natin na yung displacement, okay, ay analogous sa charge. Okay, yung first derivative ng displacement is analogous sa yung velocity is analogous dun sa current. Okay. Yung second derivative ng displacement, which is acceleration, ay analogous sa Q double dot, okay, which is multiply that by L, then we have yung voltage across the inductor. Okay, and yung mass dito, okay, yung mass is equal to, or mass is analogous to the inductance, di ba? Kasi kanina sinulat natin to na L d squared Q dt squared, and yung di ba sa Newton's laws is mx double dot. Okay, so yung m dito is analogous to the inductance. Okay, and what else? So wala pa tayong dito, wala tayong damping force. And then ano pa ba ang nakuha natin dito? Okay, so ito originally ito equation ito was written as mx double dot plus kx, okay, equal to 0. And if we compare it here, yung k is analogous to 1 over c. Yung k na ito is analogous to 1 over c, right? Okay, so yung spring constant is analogous to the inverse of the capacitance. And then yung driving force okay, is analogous to E. But since nga yung E is not, yung EMF is not sinusoidally varying, we can just treat it as a constant and put it on the other side and write it, our equation in this way para maging pareho siya dito. Okay, now notice na if I take Q dot, okay, dq dt, then itong Q1 will just be equal to 0. So walang loss of generality. And if I take Q double dot, then that's still 0. So wala tayong issue when we take the derivatives. Okay? So which means na pwede nating straightforward na compare, di ba? So if x is q, then our solution is q is equal to some amplitude, okay, a, and then cosine ng omega naught t. Okay, and let's just leave it at that, okay, for reasons na i-explain ko in a little while. Okay, ano tong omega naught pala na to, by the way? So ang omega naught dito, sorry, ang omega naught sa spring mass system is square root ng k over m, and ang analogy niyan is 1 square root ng 1 over LC. Okay, and that's where we get yung yung time constant. Omega naught is equal to 2 pi f square root ng 1 over LC, or yung time constant is equal to 1 over 2 pi, 1 over square root ng LC. So this is the time constant of this electrical system. So now to get the amplitude here, okay, to get the amplitude of the charge, then we simply apply the boundary conditions. If Q is equal to Q naught at T equals 0, okay, ibig sabihin yung current is also equal to 0, then this gives us T equals 0 is 1, so A, then Q naught is equal to A. So then, okay, this gives us, wait, Q is equal to A times cosine, Q is equal to Q naught A, Q naught cosine omega naught T. Okay. Cosine omega naught T. Okay, and maybe to complete yung picture, if I adjust, hindi, okay na yan. So we can keep it like this. Okay, so Q is equal to Q naught omega naught T. Okay, let's see. Okay, i-repeat ko yung solution. Okay. May kulang kasi we need to incorporate Q1. Okay, so kailangan natin incorporate yung Q1. So our solution will then be, so in this particular case, yung X natin is analogous actually to Q minus Q1. Okay, and that is the reason why if we take the derivative of of X, then we get Q dot, kasi Q1 just becomes equal to 0, and Q double dot is just Q. X double dot is just analogous to Q double dot. Okay? So that's why hindi na natin nilalagay yung Q1 dito. So walang Q1 dyan. Okay, so in this case, ang ating solution talaga is Q is equal to uh, huh? Q of T. Okay, so Q minus Q1. Okay, kasi yun yung ating ano. is equal to A cosine omega naught t. Yeah. So at t equals 0, Q is equal to Q naught, and I is equal to 0, of course. So at t equals 0, cosine omega 0 is 1. So A is equal to Q naught minus Q1. Okay, so that's it. So Q is equal to Q1 plus Q naught minus Q1 times cosine omega naught. Okay, now we didn't write any delta term there kasi okay, hindi na natin ilagay yung delta term dito. Kasi for this electrical system, yung current is equal to 0. Okay, which means na, and since yung current is sinusoidal, then nag-start siya from 0. So dapat 0 siya. So wala siyang phase difference, okay, pagdating sa ano. Or hindi, wala, ang delta is essentially equal to 0. Okay, so this is for a system without any damping. Okay, now if we consider damping, ano ang magiging mangyayari dun sa system natin ngayon? Oops. Hmm. Okay, mali yata akong nalipat. So dapat, okay, so dapat yan. Now if we consider a circuit with damping, ano nang mangyayari dito ngayon? So if we apply Kirchhoff's rules, then of course piliin natin yung direction. Okay, let's choose this direction. Even though it's sinusoidal, let's choose the positive direction to be that way, counterclockwise. So basically it's just VL plus VR plus VC is equal to E naught sine omega t. Okay, now we have a driving force which is sinusoidal, and then we also have a damping force. Okay, saan galing yung damping force? Ang damping force is of course yung resistance. Okay, and VL is just di dt. Yung resistance is IR, and then yung VC is Q over C. So equal to sa E naught sine omega t, and since I is equal to dq, I is equal to, okay, since I is equal to Q dot, then we have L Q double dot plus R Q dot plus Q over C is equal to E naught sine omega. Okay, and yung analogy niyan is X double dot plus um ano na nga, R over L, okay, B X dot plus K X is equal to yung driving force na F, okay, which is a function of time. Okay, so yung B in this case, okay, ay nakita natin na analogous sa, sorry, this should be MX. MX. Analogous sa resistance. Okay, which is 'di ba, as we expect, kasi 'di ba ang resistance, ang ginagawa ng resistance is just to limit the amount of current that is flowing through the circuit. And that's what essentially yung ginagawa nung air resistance, okay, to limit the flow of any moving object. Okay, okay. So alam na natin ang solution dito, right? Ano ang solution dito? Okay. Of course, ang solution ay magde-depend kung ano yung ang tawag dito, kung ano yung dominant, right? We need to consider b squared minus yung discriminant, right? So kung critical damping or overdamping or underdamping. Right? So, ano ang pwede nating gawin? Let's consider the case na kung saan ito ay underdamped. Okay, or underdamped. Okay. So, pag ito ay underdamped, pag underdamped, ang solution natin ay, remember na ang solution pag underdamped ay x equal to exponential minus beta t, okay, cosine omega 1t minus delta. Okay, and in this case, ano na mangyayari dito? Okay, so, I or Q, ah, Q is equal to exponential minus beta t cosine ng omega 1t minus delta. Okay, let's see. Ano yung beta? Wait. So, anong beta in this case? Ang beta is a parameter, okay, na sinet natin. So, this is actually 2 beta. So, ito, okay, so when we write this as, okay, when we write this as x double dot plus b over mx dot plus k over mx is equal to f of t. This is actually, this is 2 beta and this is omega naught squared. Okay, b over, so ang beta is b over 2m. So, in our case, ang beta, okay, so dito, okay, so q double dot plus r over l, q dot plus q over lc is equal to e naught over l sine omega. Okay, so ang q double dot is, o ang 2 beta ngayon ay ito. And ito yung, itong 1 over LC yung omega naught squared. Okay, so beta is just R over 2L and omega naught squared is equal to 1 over LC. Okay, and from there, we know that omega 1, okay, is the difference between omega naught squared at saka beta squared. Okay, so yan na yung ating solution. So ito yung ating solution. Ito yung ating solution. And then we just need to define what beta is and what omega naught, omega 1 squared is. Okay, so straightforward. Okay, okay, so what about in the case of critically damped? Okay, so critical damping, oops. Mm, mm. So pag critical damping, ang solution natin is x of t is equal to a plus bt exponential minus beta t. Okay, and then we just need to figure out kung ano itong mga coefficients na ito. Okay, so we already know what beta is. Okay, we just need to figure out yung coefficients based sa initial conditions. Okay, So in the case of Q of the charge of or in the electrical systems is A plus BT exponential minus beta T. Okay, where we know beta to be equal to R over 2L. Okay, now in the case of overdamping, okay, ang solution natin is XT, okay, equals sa exponential minus beta T A1 exponential omega 2T plus A2 exponential negative omega 2T. Okay, ang omega 2 dito is this time it's B squared minus omega naught squared. So nauna yung B squared. Okay, so what we have is QT is equal to exponential minus beta T A1 exponential omega 2T plus A2 exponential minus omega 2T. And omega 2 is equal to square root ng B squared minus omega naught squared. Okay, so any questions so far? Okay, what about, of course, yan ay yung particular solution. Okay, what about yung complementary solution? Okay, so pag merong driving force, what do we need? Sorry, complementary solution ito, pag merong driving force, then we need to have a particular solution. Ang particular solution is given by xpt is equal to A over square root ng omega naught squared minus omega squared plus 4 omega squared beta squared cosine omega t, okay, minus delta, where delta is equal to tangent inverse ng 2 omega beta over omega naught squared minus omega squared. So in the case of the electrical systems, Q of T is equal to A over omega naught squared minus omega squared plus 4 omega squared beta squared, and then square root cosine ng omega t minus delta. Okay, and yung delta, of course, has this same form. Okay, yung mag-iba lang dito, of course, ay yung beta. So yung beta is R over 2L. Okay, yung omega, of course, is the oscillation frequency nung driving force. Okay? Okay. Now, of course, to describe electrical systems, ang kailangan talaga natin ay yung current, di ba? Kasi we need to understand what is happening to the current. The charge that's, well, it gives us limited information about what is happening to the system. So we need to take yung derivative ng charge with respect to time. So this becomes our current, I. Okay, and if we do that, okay, by the way, itong A na ito is not A but E naught. Kasi remember na given na yung amplitude. Okay, so that's E naught. Okay, and if we do that, okay, saan na ba yun? Ang omega naught squared is, saan na yun? Omega naught squared is 1 over LC and ano pa? And then beta squared is 1 over, is R over 2L. And if we include all of those parameters, then we have E naught over square root ng R squared plus 1 over omega C minus omega L squared times sine omega T minus delta. Okay, so basically, papalitan nyo lang itong omega naught squared nitong 1 over LC. And then papalitan nyo rin yung beta squared nitong R over 2L. And then you should be able to get this expression. Okay? Okay? Then, of course, if we take the derivative of I with respect to, tawag dito, if we take the derivative of I with respect to time and multiply it by L, so we have VL, so L di dt is equal to L dq double dot, LQ double dot. Okay, then we have negative omega L E naught over square root ng R squared plus 1 over omega C minus 1 omega L squared. Okay, and then cosine omega T minus delta. Okay, or let's put this into some variable V, which is a function of omega. Then we have VL is equal to V omega cosine omega T minus delta. Okay. Okay. Now, you probably have some questions. Of course, ang isa sa mga question niyo siguro is, paano nangyari ito? Well, consider it as part of part of your exercise, okay, to show na yan ay equal. Okay. Now, another thing that you would probably okay, not in this example pala. Kasi yung time dependence ay nandito lang sa okay, so medyo straightforward naman yan. Constant naman tong coefficient. Okay. Okay. So, yun lang yung sigurong um, hindi kumpleto dito sa solution na ito na diniscuss natin. Okay, so try to do that. And if you encounter some problems on how to show that they are equal, okay, saka nyo ako lapitan, okay, via email or via consultation sa KA303 or on Thursday. Okay? Okay. Now, what else? Okay, now pwede nating alamin kung saan yung maximum value nung V omega para makita natin yung resonant frequency. So to get the resonant frequency, okay, we take the derivative of V omega with respect to omega. Okay, and set it to 0, of course. Okay, and V omega is given by this, yung blue na ito. So, ano yung sagot natin dyan? Yung sagot natin dyan is negative omega L E naught. Tapos, yung expression sa loob ng square root 1 over omega C omega L squared. Okay, and divided by ano to? Divided by R squared plus 1 over omega C minus omega L squared, and then cube root. Okay, of course, ito mawawala dahil we took the derivative. Okay, and well, actually, hindi naman nagmamatter yan kung nandiyan yun o hindi. Kasi pag sinet natin to 0, ito lang yung kailangan natin i-evaluate. Okay, so we set that to 0, then we have R squared plus 1 over omega C plus or minus 1 omega L squared. Set that equal to 0, which gives us the maximum value, which is 1 over square root ng LC minus R squared C squared over 2. Okay. So, yan yung maximum value ng frequency. Or yan yung resonant frequency. So, Okay, questions? Questions? Wala. Okay. Now let's consider this next problem. Okay, so yun yung examples nun sa ano sa oscillations. Now we consider this problem. Okay, we go back to ano to Newton's laws. Okay, so let's begin with this. Actually, okay. So a particle of mass m slides down an inclined plane under the influence of gravity. If the motion is resisted by a force F is equal to F is equal to kmv squared, show that the time required is to move a distance d after starting from rest is t equals inverse hyperbolic ng cosine exponential kd over square root ng kg sine theta. Okay, so and then meron ditong tawag dito integration formulas okay na gagamitin. Okay. Now in the exam, if just in a case na nakalimutan kong ibigay sa inyo yung integration formula, and if you need it, okay, just let me know and ibibigay ko sa inyo. Okay, so para hindi niyo na i-derive. Okay, so let's see. Ano ang first step dito? Okay, ang first step dito, of course, is to draw a free body diagram. Okay, then we have a particle of mass m sliding down an inclined plane under the influence of gravity. Then we know that in this system, we have these forces, mg, okay, yung normal force, and ano pa, yung resistive force. Okay. If it is sliding down, then that is the resistive force. Okay, yung F. Okay, F na ito. Okay, so now we draw the equations of motion, or we write down the equations of motion along the x tsaka along the y. Along the y-axis, it doesn't give us much. Okay, of course, ilagay din natin yung ating coordinate system. So let's consider this plus y, and this is plus x. Okay, so ang components ng weight ngayon, if this is theta, then this is cosine theta, and this is sine theta. Okay, so along the x-axis, so if we sum the forces along the x-axis, we have n minus mg cosine theta. And since there's no acceleration along the y-axis, along the y-axis, then this is just 0. So n is equal to mg cosine theta. Okay, now by the way, one of your classmates brought this up to me nung sa email, okay, while when she asked a question. I think dun sa isa sa mga exercises, I wrote this equation down, and then ang nilagay ko is mg sine theta. Now if you find that, then that means that obviously it's just a mistake on my part. That should read mg cosine theta. The normal force should be equal to mg cosine theta. Okay, so let's now consider yung forces along the x-axis. Okay, yung forces along the x-axis is of course mg sine theta, okay, minus kmv squared. And since there's an acceleration along the x-axis, then we write mdv. Okay, this time sinulat natin to na mdv dt, hindi md squared x dt squared, kasi yung variable of integration natin is v. okay, with respect to time. So it will be easier to integrate, to find V first. Okay. All terms ay merong mass, so magka-cancel yung mass na yan. And we are left with dv dt is equal to g sine theta minus k v squared. Okay, and if I write, let's see, okay, if I factor out k dito sa right-hand side, k g sine theta minus v squared, okay, para lang maging mas madaling gamitin yung integral equations na nandiyan dyan. So we have 1 over k dv over, sorry, g over k to. G over k sine theta minus v squared. And this is equal to d dt. Okay, ang ating initial condition ay, ano sabi sa initial condition? The motion to move a distance d starting from rest, which means na, okay, yung initial condition natin is at time t equals 0, then v is equal to 0. Okay, so kung ano man yung constant na lalabas dyan, it'll just be equal to 0. Now, we can integrate this. Okay. Okay, so at t equals 0, yung v is equal to 0. Okay, so dv dt, and you can just solve for v and then write t here. Okay, so now this expression or this integral, okay, we can use here. Na kung saan yung, ano ba, yung a is equal to 1 or negative 1, tama ba? And b is just 1 over. Okay, so by comparison, so we have a is equal to 1 and b is equal to gk sine theta. Okay, so para maging equal yan, kailangan na naman natin ng negative sign dito. Okay, so kasi yung b squared nandito sa may minus sign dyan, and then yung a squared, x squared na dito. And in this case, yung v squared dito, or we can simply set para mas madali, no? A equal to negative 1 na lang, and b is equal to negative g over k sine theta. Kung mas gusto niyo yung ganyan. Okay. Okay, so from there, we get, okay, anong gagamitin natin na solution? We can use any of this, but we're looking for a solution where cosine hyperbolic theta is involved. So either cotangent, hyperbolic cotangent or hyperbolic tangent. Okay, mas madaling gamitin yung hyperbolic tangent kaysa cotangent, at least in my case. Well, of course, the condition is that ax squared, if we use that, it needs to be that ax squared is less than b squared. So if we're going to use that, then x squared must be less than b squared over a squared, or v squared must be equal to g squared over k squared g squared over k squared sine theta. G squared over k squared sine theta. Okay, so ito yung condition para gamitin natin yung hyperbolic tangent. Okay, so we get ano ba? V to be equal to, from here, negative 1 over AB. So negative 1 over AB. So that's square root, no? May square root tayo dyan kasi B squared. Okay, so V is equal to G over K sine theta and then a square root. Okay, and then okay, tangent, hyperbolic tangent ng AXB. Okay, hyperbolic tangent. Okay, ng AX. A is -1 and X over B. Over B. So, square root ng okay, wait lang. 1 over AB. Huh. I think I may be using the wrong equation. Okay. Yes. Okay, anyway. Let's see. Tangent hyperbolic now. So, ano sabi dito? AX over B over. So, V, X is V. X is V. So, tangent hyperbolic now. Okay, ganito na lang. So, let me just write it this way. GK sine theta and then T. Okay, and then equals a dx dt. Okay. Wala dapat ito. So I may have used a different equation earlier. Saan galing yung K? Saan galing? Okay, anyway, let's just continue. So let's see. V is equal to this expression, and then if we integrate one more time, we get x is equal to g over k sine inverse. Okay, dito pwede na natin gamitin itong expression na ito. Sine inverse ng g over k sine theta and then square root okay, ng integral ng tangent hyperbolic ng square root ng g k sine theta t dt okay, and this will give us x is equal to square root ng g over k sine theta ln. Okay, base dito sa equation na to, no? ln ng hyperbolic cosine. ln ng hyperbolic cosine ng square root ng gk sine theta t. Of course, yung coefficient ay kailangan natin ilabas gk sine theta plus c prime. Then, yung boundary condition dito is at t equals 0, nag-start siya from 0, and then yung final position niya is d. Okay? So x is equal to at t equals 0, c prime, x equals 0. Okay, which implies na yung C prime ay equal to 0. So, and then at the final position or at some final position T, then yung X ay nag-travel na ng distance na D. Okay, so this becomes D and the square root ng G over K sine theta, and then ln ng cosine hyperbolic ng square root ng GK sine theta times T all over square root ng GK sine theta. Magka-cancel yung G sine theta dito na square root. Okay, at matitira yung K. Okay, so we have D is equal to 1 over K ln ng cosine hyperbolic ng square root ng GK sine theta T. And we can simply isolate T, and T will be equal to cosine hyperbolic ng E dk. Okay, pag kinuha natin yung, multiply natin yung K dyan, and then kunin natin yung exponential on both sides, mawawala yung ln, then we get square root of GK sine theta. And that gives us our time. Okay, so may konti akong utang sa inyo at ang utang ko is how this was derived. Okay. Let me just go back to my notes. Kung mali yung ginamit ko na. Integral. Okay? So anyway, yun yung derivation ng time. Okay, questions? Hmm. Yeah. Well, mali nga. Of course, you can solve this by trigonometric substitution. Anyway, pwede namang ma-solve to by trigonometric substitution. Anyway, ipakita ko sa inyo yung solution later. Okay, let's see. One more. Delete. Oops, one. Okay, let's see this exercise 2-14. By the way, itong mga exercises na to ay nandoon sa ano, no, end ng chapters nung book and ng chapter 2 nung ni Marion, nung book na Marion. Okay, so 2-14, a projectile is fired with initial speed v naught at an elevation angle of alpha up a hill of slope beta. Okay, so how far up the hill will the projectile land? At what angle alpha will the range be maximum? And what is the maximum range? Okay. Siyempre, kailangan ma-visualize nyo muna kung ano nangyayari. So you have to draw what is happening. Okay. Initial speed v naught at an elevation angle of alpha. Okay, up a hill of slope beta. So ang slope has an angle beta, and then the projectile was fired at an angle alpha. Okay, so this is the angle alpha. So alpha is greater than beta. Okay? And of course, ito yung range na hinahanap. Okay, so this makes things a little bit complicated. Okay. Now, of course, you can use Newton's laws, pero pwede nyo pa rin gamitin yung ano tawag dito? Equations of motion for kinematic equations. Okay. And bakit natin pwedeng gamitin yun? Kasi at this point, we already know na yung kinematic equations was derived or were derived from Newton's laws. Okay, ginawa natin yun in one of our previous meetings na kung saan nag-start tayo from Newton's laws and then we derived the kinematic equations by simply integrating once to get the velocity and twice to get the acceleration. Okay, and if you recall, yung ating kinematic equations is our x equals v naught cosine theta t. Pero syempre hindi to theta. This will be alpha. Remember, okay, alpha yung ating x. And of course, along the x-axis, wala tayong acceleration due to gravity. And of course, that only happens if the axis is chosen to be like this. And then V naught cos sine beta. Sine alpha t minus 1/2 gt squared. Okay, and if we solve for t, and we replace t solve for t from the equation for x, and we replace that dito, okay, we get, okay, so t is equal to x over v naught cosine alpha t. Cosine alpha t, cosine alpha, sorry. And y will then be equal to v naught sine alpha x over v naught cosine alpha minus 1/2 g x over v naught cosine alpha t squared. So we have y is equal to tangent alpha, x tangent alpha minus 1/2 g over v naught squared cosine squared alpha x squared. Okay, and if so how do we do this now? So we want to solve for the range R. Okay, ngayon, we can see that the range R should be related to beta, right? So if this is R, okay, if this is R, okay, ito yung height and yung distance, right? So itong distance na to, so ito yung R natin, no? And this is beta. So this will be R cosine beta. Yan yung adjacent side. And this will be R sine beta. Yan yung opposite side. So we get the range to be okay, so y is R sine beta and x is R cosine beta. R cosine beta tangent alpha minus 1/2 g over v naught squared cosine squared alpha r squared cosine squared beta. Okay, and anong gagawin natin dito ngayon? Okay, so remember we're solving for R. So we have, so mangyari dito ngayon ay R, wait. times. Okay. So, bakit may times dyan? Kasi this is r squared and then this is r. So, pwede kong i-factor out yung r sa lahat, di ba? Ang matitira ay r d over v naught squared cosine squared alpha cosine squared beta. Ito yung term na ito. Then may 1/2 pa pala doon. Okay, then ito ililipat ko dito. Okay, then I get plus r, wala na yung r. So sine beta or cosine beta, cosine beta tangent alpha minus sine beta. Okay. And of course, I multiply everything by -1. And then the right-hand side will be equal to 0. Okay, again, paano nakuha yan? Para lang clear. Okay. So first, itong buo na to, nilipat ko sa kabilang side, then magiging positive na lahat. Ito magiging negative to. Okay, kaya may negative. Wait. Cosine beta minus negative. Okay, negative cosine beta tangent alpha minus sine beta. Okay. So I still have, well, this is this is an equation with r squared as the highest power at dalawa yung solutions dito. Yung trivial solution is r equals 0. And then yung second solution is yung r, okay, which is equal to all of these. So if we do the math, then we get r equals sa cosine beta tangent alpha minus sine beta all over 1/2 d over v naught squared cosine squared alpha cosine squared beta. Okay, and all we need to do now is simplify. So tangent alpha is what? Tangent alpha is sine alpha cosine beta. Cosine alpha. Okay, so r will then be equal to cosine beta sine alpha over cosine alpha minus sine beta all over 1/2 d over b naught squared cosine squared alpha cosine squared beta. Multiply natin ito by cosine alpha, we get r equals sa taas may cosine beta, sine alpha minus sine beta, cosine alpha. So this is cosine alpha or sine alpha minus beta, right? So, and if we simplify, we have 2 v naught squared cosine alpha, okay, times sine alpha minus beta all over g cosine squared beta. Okay, so yan na yung ating maximum range ngayon. So ito yung R na hinahanap natin dyan. Okay. Next question. At what angle alpha will the range be maximum? So at what angle alpha will the range be maximum? So, syempre, to get that, kukunin natin yung derivative ng R with respect to alpha. And then we set it to 0. Okay, so this gives us, ilan yung alpha natin dito? 1, 2. So this will give us 2 v naught squared over g cosine squared beta Okay, and then cosine alpha. Okay, negative sine alpha minus beta, and then plus cosine alpha minus beta, right? Okay, let's see. Alpha minus beta. Cosine. Okay, and this we set to 0. Okay, if we set that to 0, then what do we get? Sandali ah. Cosine alpha sine alpha minus beta. We get this really complicated equation. Negative sine alpha sine alpha minus beta plus cosine alpha minus beta is equal to 0. Then we have, lipat ko to sa kabilang side. Tangent alpha equals tangent alpha minus beta. Okay, let's see. Dali kung tama yung ginawa ko, cotangent. Cotangent alpha minus beta. Nope, D and D, that's R. Thank you. R, and this is also 1 over cosine. Okay, thank you, Fritz. Okay. So, anong ibibigay sa atin na equation na ito? Okay. Ano bang shape ng tangent alpha? At ano ang shape ng alpha minus beta? Ano sa tingin nyo? So, syempre, equate natin yung alpha and then equate din natin yung alpha minus, tangent alpha, yung tangent alpha sa right-hand side, and then yung cotangent alpha minus beta din sa left-hand side. Graph natin yan pareho and then titignan natin yung points of intersection. Okay, and when we do that, we get alpha is equal to pi over 4 plus beta over 2. Okay. Okay. So, may questions pa? Yes. Tinatype mo ba yung question mo? Okay. Yes, tama. Nakalimutan ko yung G. RG. So, dapat ito G. Okay. Thank you. Any other questions? Okay, so ano ngayon yung maximum na range? Yun yung next, yung final question. So to get the maximum range, we simply input yung alpha, expression for alpha doon. So maximum range is equal to 2 V naught squared over G cosine squared beta. Tapos cosine alpha, cosine pi over 4 plus beta over 2. Okay, sine, ano na nga yung expression natin? Pi over 4. Wait. Sine alpha minus beta. Alpha minus beta. Okay. Alpha minus beta is minus beta over 2. Okay. Okay, so now we can use the identity sine theta minus sine sine theta minus sine theta 1 minus sine theta 2 is equal to 2a or 2 cosine 1/2 theta 1 plus theta 2 times sine 1/2 theta 1 plus theta 1 minus theta 2. Okay. Ito. And that's, okay, this gives us sine theta 1 is pi over 4 minus sine beta over 2 times 2 is equal to cosine pi over 4 plus beta over 2. Sine pi over 4 minus beta over 2. So R max will then be equal to sine pi over 4 is square root of 2 over 2. So this would then be reduced to 2 v squared g cosine squared beta, okay, times sine pi, okay, sine pi over 2. Tama, sine pi over 2 kasi 1/2 nga pala yun. Sine pi over 2 pala to. And then sine beta, sorry. May 1/2. May 1/2 pala dito. Okay. Minus sine beta. Okay. Then divided by 2. Okay. Now sine pi over 2 is just sine 90. So this is just 1 minus sine beta. Okay, and then we can express cosine squared beta in terms of sine then. So we get, cancel yung 2 dyan. Then we express this as sine beta. So we have v naught squared g. Sa ibabaw is 1 minus sine beta. And then sa ilalim is 1 minus sine squared beta. Okay, and we know from mathematics na 1 minus sine squared beta is just 1 minus sine beta times 1 plus sine beta. Okay, so magka-cancel din. Mawawala tong 1 minus sine beta dito at ang matitira is 1 plus sine beta. So, R max is equal to v naught squared over g 1 over 1 plus sine beta. Okay, and if we say that beta is equal to 0, if beta is equal to 0, okay, ano ang sine 0? And sine 0 is 0. Then R max is just v naught squared over g, which is yung expression na alam natin for the maximum range pag beta is equal to 0, pag hindi inclined yung plane. Okay? So, everything is consistent. Okay, dito sa solution. Okay. Okay, any questions? Okay, so, kung wala nang tanong, just, well, I do have a question. Okay, a practical question. Feeling nyo ba ready na kayo sa exam sa Saturday? You can reply sa sa chat box. Ano tingin nyo? Feeling nyo ready na kayo sa exam sa Saturday? So anong kailangan nyo para maging ready? Practice, right? Yes, kailangan nyo mag-practice. That's right. Practice natin on Thursday. Okay. Well, you also have, well, how about this? Okay, so I was thinking na can also spend yung, well, if you want, you can spend your weekend practicing, okay, and we can just move yung exam on Tuesday. How does that sound para sa inyo? What about yung iba? Yes, para dun sa mga nag-182, okay, then you can take the exam on Saturday or on Wednesday kung ipapamove ng mga kaklase ninyo. Okay, so anyway, so let's see. Take a look at the chat box. Okay, I'm going to paste a link there. Okay, and you answer yung link. Okay, and let's see what we have. Okay, so this link is about schedule ng Physics 161 exam. I'm also going to send it sa email para dun sa mga kaklase ninyo na hindi present today. Okay, and it's just a survey kung gusto niyo na mag-exam sa Saturday or dun na lang sa on a class day. Okay. So, yun lang yung dalawang options. Hindi na natin siya pwede i-move further. Okay. At least mabigyan lang kayo ng konting time para mag-aral. Okay, so you can answer that and then anong tawag dito? And then send you the decision sa, ano, I'll tell you the decision sa uh, Thursday. Okay? So on Thursday, we're going to meet face to face. Sabi ko nga, I'll be a little late, but this is what you are going to work on as practice. Okay? So para ma-practice kayo, wag muna kayo mag-thank you dahil magdedepend yan sa voting nyo sa ano, voting ng mga kaklase ninyo. Okay, so para ma-practice kayo, you choose a problem end, dun sa problems na nasa end ng chapters 2 tsaka chapters 3. Okay? Pagkatapos, ganito ang gawin natin para organized kayo. Okay, pumunta kayo dun sa Google, sa VLE natin. Okay, and dun sa Jamboard, okay, ilagay nyo yung problem na gusto niyo i-solve. So pick one problem from chapter 2 and one problem from chapter 3, and then i-solve nyo. Try nyo i-solve as early as now, and then para sa Thursday, pag-uusapan na lang natin. Okay? Pero pwede nyo rin i-solve sa Thursday kung gusto niyo. Pero mas maganda kung ma-solve nyo na by Thursday. Okay? So punta kayo sa Jamboard. Okay, then okay. And then kuha kayo nitong ano, saan ba 'yan? Sticky note. Tapos lagay niyo pangalan ninyo, di ba? Tapos ilagay niyo, oops, sorry. Kulang 'yan. Ilagay niyo kung ano yung problem na gusto niyo i-solve sa chapter 2, di ba? 2.1 and then 3.1. Okay, tapos save nyo. Yan. So meron na kayong ano, para makita ng mga klase nyo kung ano yung sinolve niyo. Kung ano yung gusto nyo i-solve. Okay? Tapos, ang gagawin natin sa Thursday is yun, check nga natin yung solution ninyo. And then, kukolektahin natin ang lahat ng solutions na yun, and then, isi-send ko sa inyo. Okay? Para at least meron kayo nung sort of compendium or collection ng solutions mula sa iba't iba yung kaklase. Okay ba yan? Pwede nyo nang gawin yan kung gusto niyo. Okay? So, pumili na kayo ng problem from chapters 2 and chapters 3. Okay, so, kung wala nang ibang